Hello guys, this is NeaOnnim-Tech. This is the start of a season where I bare metal program the STM32. Simple tasks, short videos, just 5 to 6 minutes each. Today I will show you how to set up a GPIO pin as an output on the STM32. No HAL, no libraries, just registers. And yes, this is also a learning curve for me, so let's go. I'm programming everything in Keil MicroVision. There is a free version, and if you want a setup tutorial, just drop a comment and I will make that in a separate video. For now, I will skip the boring setup part. All STM32 chips with the ARM architecture share a similar structure, so this method works almost with every series of the STM32. To set up the GPIO as an output, we will do the following steps. First, I include the STM32 device file with an #include directive. Then, I create the main function, the heart of every embedded C program. At the top, we will configure the GPIO and then enter a while loop that toggles the pin on and off. To start the configuration, we turn on the clock for the peripheral, which is located in the RCC, the reset and clock control register. In this example, we'll turn on the clock for the GPIO-A module. Next, we reset the mode register of the GPIO. This is a habit I developed to make sure I really set the configuration from a known state. In this line now, we configure the pin we want to use as a GPIO output. In this example, we will use the GPIO pin A0 as an output. After that, we create our power loop, which will toggle the pin state. For that, we create a while one loop. To set the GPIO output to high, we will use the BSRR register, the bit port set and reset register, a very practical register to set and reset the GPIO. Now we have to create a delay. Normally, I would use a SysTick timer or a general timer for a proper delay. But today we are lazy, so I'm dropping some ASM knob instruction inside a for loop. To set the GPIO pin back to low, we will again use the BSRR register. Be aware that this register is split into two parts. The low word contains the BS bit set bits and the high word contains the BR bit reset bits. We can simply copy the definition we used above to set the GPIO and change BS to BR. Finally, we create another delay by copying our lazy for loop implemented above. Now we compile and hope for no errors. I am using a Segger J-Link debugger, but any ARM debugger will do the job. If you need a tutorial on how to configure the debugger, just let me know in the comments and I will make a separate video for it. After configuring the debugger, we can start a debug session. The onboard debugger lets us watch the GPIO register toggle in real time. In the GPIO register viewer, we can collapse the ODR, the output data register. Then we can run our project. We should now see the ODR bit 0 toggling. Don't judge the delay, it's random for now. But if you want to make it precise and sexy, I'll show you that in a separate clip. And that's it, GPIO output configuration on STM32. No HAL, no fluff. If you didn't know, now you know.